Hello everyone, my name is Lenin Msundire, and today I shall take you through the project that we carried out on digitization and adoption of BMS, which is Breeding Management System by Kenya Agriculture and Livestock Research Organization, KALRO. And here we were emphasizing or focusing on maize and wheat breeding programs. For this project, there were 4 major teams that were involved, or organizations. The first one being KALRO, who are the custodians of the 2 breeding programs. We also had CMIT, Excellence in Breeding, and also Integrated Breeding Platform, IBP. What were the challenges that we were trying to address from this project? The first one was the lack of institutional breeding data management system for KALRO wheat and maize breeding programs. In other words, there was no system which was being used. Breeders were generating their trials and nurseries in different different programs, be it field book, CropStat, or some of them they were even using Excel. And the worst case scenario, there were breeders who were manually generating their trials and nurseries. The second one, difficult to effectively integrate digital tools in these programs. Since there was no way or systematic way of accessing the data or weighing the amount of data or workload that was available and complementing that with the relevant digital tools, it was very difficult to establish the tools that were required and the amount as well. And then the third one, historical data was not readily available for analysis over multiple years to try to identify the trends that are there in the breeding program. This was mainly due to the fact that breeders were keeping the data in their personal computers, or either data was still in hard copies in offices, and as a result, one could not analyze data over a long period of time because of lack of a system which could keep the data for use. In terms of the teams that were involved in KALRO digitization, we had 4 main teams, as indicated earlier. From KALRO, we had maize lead, Dr. Dixon Ligeo. We also have had Dr. Machiria, who leads the wheat program. We also had Joyce Malinga, who is the Director of Research for KALRO Institute. From IBP, we had Mebo Mulenga, who is based in Nairobi, who was the interface member for IBP, who worked with to achieve most of the digitization process which happened. Mebo was also being assisted by Corina. There was also Fernando and also Jan Eric. These are the 4 people who were very integral in terms of achieving or effort to achieve this project. For EIB, we have Bish Das, who is the coordinator for NAS projects. Myself, Lenin Msundire, breeding optimization specialist for all national programs in Africa. And for the CGI Center, we had Kate, who is from the EBS data manager, who was also assisting us. From EIB, we also had Liz from Module 5, who was also assisting with this project. In terms of achievements that we had from the project, the first one, as it stands now, the KALRO serial breeding program has a cloud-based BMS that is available for them for use. Now they can easily trace their historical data. They can use their current BMS program to generate trials and nurseries for all current and future projects. In terms of trial data sets that were collected from breeders, as they were being generated from different breeding softwares and programs, they also had different trait ontologies, with some of them not universally used by most breeders. In other words, these ontologies needed a bit of some explanation from the respective breeders for people to understand. But through the use of BMS and EBS, now we are having ontologies which are universally acceptable, and they can easily be used by any scientist to analyze or go through the data that is available. In terms of historical data loaded onto BMS, I'll start off with maize. For maize, from 2002 to 2010 to 2020 data was loaded onto BMS, and this data is ranging from preliminary yield trials, intermediate yield trials, and advanced yield trials. This data is readily available and has been loaded onto BMS. And for wheat, we have 48 sets of data for both trials and nurseries that have been loaded onto BMS, and these are now readily available. And then in terms of collection of metadata, we're looking at data that is associated with trial sites, where we are referring to the latitude, altitude, latitude, longitude, state and location type. These have also been recorded and uploaded onto BMS and are readily available for exploration in terms of use during trials and nursery. In terms of crop cycles, these have also been documented for the two programs. And within the same project, there was also training of key scientists and technicians on the use of BMS. And to indicate that there was success from this training, this is being evidenced by trials for 2020 for both programs, which were generated on BMS. A graphical representation of historical data that was loaded onto BMS is being shown in this graph or slide. For maize, 35 sets of trials were loaded onto BMS, and these range from PYT, preliminary yield trials, IYT, intermediate yield trials, and advanced yield trials from 2002 up to 2020. And these are indicated in light green. The darker green that is there, or the 3 that is there, is simply indicating 3 sets of trials that were generated using BMS for 2020 trials. And then for wheat, the 48 that is there is simply indicating the sets of trials and nurseries that were uploaded onto BMS, with the 5 indicating or showing the number of trials that were generated in BMS for 2020 season. And then fragmenting these trials and nurseries to plots or data points shows that for maize, 21,025 data points were generated and uploaded onto BMS. And then for wheat, 27,527 data points were loaded onto BMS. A brief overview of breeding management system and why we selected it for use for national programs at the moment. It's because BMS is a mature, robust system for managing germplasm, inventory, and phenotyping data in web-based system. In other words, breeders can easily access their historical data, their current nurseries and trials over the web from any point in the world. Thus, ensure that efficiency can be achieved in terms of working. The IBP is a worldwide network of support staff for deployment and training and support. In other words, these team members or staff from IBP can easily support our national programs to ensure that they effectively use BMS. And below here is a picture which is showing the team members that were involved in the digitization process of KALRO serial project. We have Mabel Mulenga, we have Fernando, and also Corina. These are the integral members which worked tirelessly to ensure that data was uploaded onto BMS. not forgetting Jan Eric as well. This interface, BMS interface, is simply showing the KALRO serial breeding programs that have already been loaded onto BMS. It's an interface window for accessing KALRO serial maize breeding programs. Impact that came out of the project: KALRO wheat and maize programs have established the foundation for digitally managing their breeding data. The second one, digital tools are coming, and KALRO will be ready to integrate and use these tools. The third one, breeders can now easily view the historical data for their programs. And this is of great importance as it gives the opportunity to analyze these trials and then establish the rate of genetic gain that is within the program. In other words, this will give an indication or a direction of what are the requirements that are needed to make sure that we improve in terms of the genetic gains and also variety turnover for the two programs. Coming also in the pipeline is the digitization devices from Module 4. And again, the digitization training team will be involved. And the tools that are expected to be coming in are package printers, label printers, seed counters, and handheld devices for recording data during trials and nurseries.